Then Philips was saying that there is something like this commercially available. If that be the case, we'll go with that.
Oh, you mean that the actual, this cable just floats?
Yeah.
Because these expand?
They might expand.
How much do they expand? A lot?
Sometimes.
Like a foot?
A foot?
Yeah. So you have to allow for anything attached to it to expand with it.
A foot is a lot.
For about 6 months, we had a plan on how we were going to install the nodes onto the suspension cables at the bridge, and included industrial zip ties. And it became apparent about a month and a half ago that that wasn't technologically the sound solution.
Making sure what we propose is functional, but also doesn't add to the budget.
We started back a couple weeks ago when we did that test, at night, where we actually checked the kind of the directional distance, the throw of the lights, and through that process, we kind of uncovered how the strategies on how to connect the cable, and I thought there's some opportunities for us to save some money and kind of time and energy. So kind of took that concept and we prototyped a couple different ways to approach it.
I think we always had a plan on how we intended to install it, but through Amy and Saeed, they said someone else had an idea that they thought would expedite the installation. And we've seen people have ideas that come from out of the blue that are actually quite good ideas.
But if you actually had a carabiner every other section?
What we ended up doing is we made some dummy versions of the rails with the lights in them and put a 30-foot section of 2.5-inch pipe, which is the same diameter of the cable, inside our warehouse, and came up with a methodology of sliding them down.
So the technique is starting from the top down. We put this just to simulate a little hanger. So the idea is like a shower curtain, and this zip ties to this, and moving from the top, he puts it on here, he just drops it down, and slides straight down the bottom. Okay.
Coming up with a scenario that we can be efficient in the field and attach these lights on the suspender cables. At the same time, do all the electrical work, wiring, conduits that we have to do along the side of, at the bottom of the deck or at the top when we attach the networking boxes together.
So there you go. And you see it just drops right into place. It takes seconds. And that's 30 feet. Boom. So you get the idea.
Why not just offset the magazine to the side so that it feeds right out along the pipe, and then you could just zip it as you go?
Sure. One of the difficulties is, like I said, the job is very hard to access. You can only access the project at night with a lane closure, and not having the funding there, we can't really go out there and do a lot of investigative work ahead of time. The fixtures that Philips make, the top quality fixtures, they're actually, they're very smart, individually IP address and all that, but to use it in this application, which is a harsh marine environment, it kind of pulls everyone back to think ahead and make sure that this is really going to work. Philips was a little concerned about having this fixture attached directly to the cables with a zip tie, which we were originally thinking, that the wind might move the fixtures enough to disconnect the nodes from the cable, and that we didn't want that to happen. So we coming up with different scenarios of how to attach the light strings to the suspender cables without actually putting too much pressure on the cable for the lights.
These are pretty snug, and we can also make them snugger if we need to.
Our initial thought was to use stainless steel banding for corrosion, UV, and all that. Ultimately, Caltrans Bridge Maintenance felt that the dissimilar materials could cause corrosion on their suspender cables. And obviously that's not going to work. Tied down, or it starts.
I think you might want to do a hole. Might want to do a hole here and a hole in the next rail and use a zip tie so that this isn't carrying the structural load.
There were a couple of concerns. First, we have to be able to securely attach the LEDs to the bridge without damaging them. That's extremely important. The second major concern was that we want to reduce the amount of effort required to get the LEDs up. In particular, we want to reduce the amount of sort of fine materials handling that needs to happen for the crews that are actually on the cable. So the goal was twofold: to create, a stable attachment and create something that made life easier for the work crews.
Because another thing you don't realize is the cable is a non-regular surface.
Right.
And then on top of it, if I went and examined the cable, it's got tons of paint and tons of dimples on it, okay? I don't think anybody's looked at what the real cables look like.
Obviously, the bridge is a suspension bridge, and with the different temperature between summer and winter, you're going to have some expansion in the cables. You know, the cables, the bridge might drop, by 6 inches a foot because of the cables, expanding due to the heat, and we want to make sure that the light cables can afford that, can actually compensate for that expansion.
So we looked at the rail solution, and the contractor from Baco said, look, I can't see how this reduces the effort in any way. We end up handling more pieces of stuff.
I'm still not seeing the advantage of the track.
Time.
Well, how is it saving you any time? I mean, you've got to snap all this stuff in and
You still-
pre-assemble all that. I'm talking about
But you still have
getting
to-
it
okay.
packaged individually from them in each run and numbered.
With these already on them?
Yeah, those could already be on. Simpler is always the best. And our thought was we get each individual light string in a bag, and we'll take that bag right into the basket and attach the string up and just start working our way down the cable, attaching the string as we go. And you've only handled the product once. The bags are actually quite small because the individual strings are only 50 to 70 feet long.
I personally think that it's a superior way, but instead of fighting, just try to let it flow. And so we also came up with a solution, which was how to attach the lights to the cable, but how to come up in a way that doesn't create tension on the wire itself.
Yeah, because if you
So we had to get a chance to kind of just talk it through, and we came up with a whole new solution that we didn't even start with, which was really great. And I think that's kind of the power of the group, right? And it's kind of what the project's about, is really working collaboratively, coming solutions. And so we did. So the piece we built was called the bridge, because it looks like a little bridge and acts as a bridge.
The little clip that I've designed to hold this thing in the rails, if we actually change the design a little bit, we can just actually use it to go directly to the cable. So it occurred to me that perhaps we could just go with a clip like this directly onto the cable, right? Modify it so that it has little feet that match the curve of the cable. And then we wouldn't need the rail. So that was the second version that came out, was this. And then quite a big opening for the zip tie. That fits on, and that curve follows the bridge cable. So you thread a zip tie through there. And then a couple of iterations later, we realized that we needed there's these data cables that go to other segments of LEDs. They're a big thick cable that also need to be attached. We didn't want to have additional zip ties to hold those into place. So we thought, okay, well, we need channels on each side of the clip for that. And we also want the clips to stay put, to be able to snap onto the cable and grip so that the work crews don't have to worry about them falling off all the time. So this is the final design. So we have the 2 channels for the leader cables or the data cables, and the central channel for this cable with a little lip so that it clips on. That's not going anywhere.
I think this is the best idea.
Yeah.
Your concern is putting pressure on the cable.
Yeah.
And with this,
Right,
Let's have a look.
we will avoid that.
right.
The original idea was
We will mold
in the
it.
groove, yeah.
No, we go out there and mold it
yeah.
so we can figure out exactly what we need.
So Tuesday, it's going to be great. We're going to go up the cables and actually look at the attachment points and how it's all connected. And then we're also going to take a still camera, and we'll take a bunch of photographs of the cable themselves, because they got paint and gnarls on them and stuff. And we're going to reconstruct a 3D model based upon that.
We had a chance to see the cables that we'd actually be attaching the lights to. And while we were up there, I thought it would be a good opportunity to take a lot of pictures of the bridge cables and attempt to do a photogrammetric reconstruction. So we were able to capture a good 3D model of the bridge And from that, I reconstructed a full-size section of the bridge that I could use for prototyping.
I have a long background in using 3D printers and stereographic printers since 1995, so I'm a big fan of it. But now it's, for the first time, it's become very approachable and very cheap. For about $2,000 you get this really great printer that prints ABS plastic. So you send a 3D model to it and literally just like a little glue gun, but it squirts out hard plastic and it builds up one little piece at a time. So what that gives us is what would normally take weeks and weeks and weeks of process of coming up with a design, having somebody make it out of clay, then or wood or whatever, and then sending out to get a prototype. Costly. We can come up with a sketch and have it printed in 30 minutes.
This is actually the clip that we're using for production. So it's really wide. It has a good notch for the data cable. I'm not sure if it's visible, but there's like the little lips on there so that it clips really securely onto the cable. Once it snaps on, it stays put.
This is a really great thing about this project is we're using state-of-the-art tools. I mean, totally state-of-the-art tools that are approachable and are very affordable in a context that solves a problem that only would exist in an installation like this.
This design snaps on, doesn't move. You can thread your zip tie through. It's designed so that it grips the zip tie pretty well. The idea is that once they're working on it up there on the bridge, things aren't flapping around and getting lost. In fact, they can probably just preload the clips with zip ties. Then you put the data cable here on the side. That also snaps in, so nothing's going anywhere at this point. It's all staying put. That. Bring it in. I use a zip tie gun. Okay. That's what you want to use. Clip them tight into place. So there we go. So that's attached. It's super sturdy. That's just not going anywhere in any direction. So we went ahead and we made 55 of these, which are on the bridge now as we speak. There's actually a test strand on the bridge held on with these.